What if the greatest discovery in science is not something we have found, but something we are missing? Modern physics has revealed a strange pattern. The more we learn about the universe, the more evidence appears for things we cannot directly observe. Invisible influences shape galaxies, alter cosmic motion, and affect the structure of reality itself. It is as if we are looking at a completed puzzle while half the pieces remain hidden. This raises a disturbing possibility. What if the universe we experience is only part of what truly exists? Tonight we explore the possibility that reality is incomplete and that the unseen may be far larger than the world we know. For most of human history, people assumed that reality consisted of everything they could see, touch, and measure. The stars in the sky, the planets, the oceans, the mountains, and eventually the atoms that make up matter all seem to fit into a picture of a complete and understandable universe. The more science advanced, the more it appeared that humanity was steadily filling in the missing details of a cosmic puzzle. Yet something unexpected happened. Instead of finding fewer mysteries, scientists began discovering evidence that the puzzle itself might be missing entire sections. Some of the strongest clues emerged when astronomers started observing galaxies in greater detail. According to the laws of gravity, the visible matter inside galaxies should not produce enough gravitational pull to hold those galaxies together at the speeds being observed. Stars near the outer edges were moving far faster than expected. By all known calculations, many galaxies should have been flying apart, yet they remained intact. This created a profound problem. Either the laws of physics were incomplete, or there was a vast amount of unseen matter providing additional gravity. Scientists could not see this missing substance directly. Telescopes detected nothing. It emitted no light and reflected no radiation, yet its influence appeared everywhere. Something invisible seemed to be shaping the behavior of entire galaxies. The mystery deepened as observations expanded across the universe. Large clusters of galaxies also displayed gravitational effects that could not be explained by visible matter alone. In some regions of space, gravity appeared to be coming from locations where no detectable objects existed. It was as if enormous structures were present but hidden from direct view. Then another clue appeared. When scientists studied the expansion of the universe, they expected gravity to gradually slow that expansion over time. Instead, they found the opposite. The expansion was accelerating. Some unknown influence seemed to be pushing space itself apart. Once again, the universe behaved as though an invisible component was affecting reality on the largest possible scales. These discoveries revealed a pattern that continues to challenge modern science. Again and again, the universe behaves as if something important is missing from our picture of reality. We can observe the effects, measure the consequences, and calculate the influence, yet we cannot directly identify the source. It is similar to seeing footprints in fresh snow without ever finding the creature that made them. What makes these clues so unsettling is that they do not appear at the edges of scientific knowledge. They appear at the very heart of it. The motion of galaxies, the structure of cosmic clusters, and the expansion of the universe are among the most fundamental observations in astronomy. If hidden influences are shaping all of these phenomena, then the reality we experience may be only part of a much larger system. The possibility is difficult to ignore. The universe keeps presenting evidence that something exists beyond what we can directly observe. Every measurement points toward unseen components that affect the cosmos in powerful ways. We are not dealing with a small gap in knowledge. We may be confronting the possibility that significant portions of reality remain hidden, influencing everything around us while staying completely beyond ordinary perception. When most people think about the universe, they imagine everything that exists. Stars, planets, galaxies, black holes, nebulae, and the vast stretches of space between them. These enormous structures seem to represent the entirety of cosmic reality. Yet one of the most surprising discoveries in modern science suggests that all of these visible objects may account for only a tiny fraction of what actually exists. This realization emerged from decades of astronomical observations. Scientists carefully measured the behavior of galaxies, the motion of galaxy clusters, and the evolution of the universe itself. Again and again, the numbers refused to match what could be explained by visible matter alone. Something was missing. The universe appeared far heavier, more energetic, and more complex than its visible contents suggested. Today, many cosmologists estimate that ordinary matter, the atoms that form stars, planets, oceans, mountains, living organisms, and everything humans have ever observed directly, makes up only a small percentage of the total cosmic inventory. In other words, nearly everything familiar to us may represent just a thin surface layer of a much larger reality. Imagine standing on the shore of an ocean at night. The beam of a flashlight illuminates a small patch of water directly in front of you. Everything within that beam appears clear and understandable, yet beyond the light stretches an enormous darkness filled with things you cannot see. The visible universe may be similar. Human observation illuminates only a small region of existence while far larger components remain hidden beyond our current ability to detect. What makes this idea so remarkable is that the unseen does not appear to be rare or insignificant. On the contrary, it seems to dominate the cosmos. The structure of galaxies, the formation of enormous cosmic networks, and even the expansion of the universe appear to be influenced by components that remain invisible to direct observation. The universe itself offers clues to this hidden majority. When astronomers map the large-scale structure of space, they find immense filaments of galaxies stretching across unimaginable distances. These colossal formations resemble a cosmic web connecting vast regions of the universe. Yet visible matter alone cannot fully explain how such structures formed and maintained their arrangement over billions of years. Something unseen appears to provide much of the underlying framework. Even more intriguing is the possibility that our limitations are not merely technological. Human senses evolved to navigate a small environment on a single planet. We perceive only a narrow range of light, sound, and physical phenomena. Scientific instruments have expanded our reach dramatically, but every new device reveals additional layers that were previously invisible. Radio waves, X-rays, gamma rays, gravitational waves, and countless other phenomena existed long before humanity discovered them. This raises an important question. If so many aspects of reality remained hidden until new methods of observation were developed, how many others still remain beyond detection today? The history of science repeatedly demonstrates that reality is larger than our assumptions. Every generation has believed it was approaching a complete understanding of the universe, only to discover entirely new dimensions of complexity. The Earth was once thought to be the center of existence. Later, the Milky Way seemed to encompass everything. Then astronomers learned that billions of galaxies fill the observable cosmos. Each breakthrough expanded the boundaries of reality. Now the evidence points toward an even deeper possibility. The visible universe may not be the whole universe at all. It may simply be the portion that interacts with our instruments in ways we can currently measure. Beyond that visible fraction could exist vast components, structures, or forms of existence that remain hidden from view while still influencing everything around us. If this is true, then humanity may occupy a position similar to ancient explorers staring at the horizon, believing they understood the shape of the world while an entire continent waited beyond sight. The universe we know may be real, but it may also be only a small fragment of a much greater cosmic reality that remains undiscovered. The strangest fact about modern science is that some of the most important influences in the universe cannot be seen directly. We often assume that if something is real, it should be visible. Yet many of the forces shaping reality reveal themselves only through their effects. We do not see them directly. We see what they do. A simple example exists in everyday life. Nobody has ever seen gravity itself. We see an apple fall from a tree. We see planets orbit stars. We see galaxies rotating through space. The force causing these motions remains invisible, yet its presence is undeniable because its influence can be measured. Science has learned that reality often reveals itself through consequences rather than appearance. As astronomers explored deeper into the cosmos, they encountered influences that behaved in a similar way but on a far larger scale. Galaxies were moving as though additional gravity surrounded them. Clusters of galaxies remained bound together despite not containing enough visible matter to explain their behavior. Something invisible appeared to be contributing enormous amounts of gravitational influence. Scientists could calculate the strength of this hidden effect with remarkable precision. They could map where it seemed to exist and estimate how much of it was present. Yet no telescope could capture an image of the source itself. It was like watching leaves move across the ground and knowing the wind is present while remaining unable to see the wind directly. The mystery became even more fascinating when researchers studied how light travels across the universe. According to Einstein's theory of relativity, gravity can bend light as it passes through space. Astronomers began observing distant galaxies whose light was being distorted by invisible concentrations of mass located between the source and Earth. The effect acted like a gigantic cosmic magnifying glass. What made these observations so important was that they allowed scientists to detect hidden influences indirectly. Even when no visible object appeared to be present, light behaved as though something massive occupied that region of space. The universe seemed to contain structures that could be measured through their gravitational effects while remaining completely unseen. Another example emerged from the discovery of gravitational waves. For generations, these ripples in space-time existed only as a prediction. Scientists could not see them or touch them. They remained hidden from direct observation. Yet decades later, incredibly sensitive instruments finally detected their passage through Earth. The waves had always been there. Humanity simply lacked the ability to measure them. This pattern appears throughout the history of science. Entire categories of reality have existed unnoticed until new methods revealed their presence. Radio waves filled space long before radios were invented. X-rays passed through matter long before anyone knew they existed. Microorganisms shaped life on Earth long before microscopes exposed their hidden world. These discoveries teach an important lesson. Visibility is not the same as existence. Reality does not depend on whether human beings can perceive it. The universe may contain countless influences operating beyond the limits of our senses and instruments. The deeper scientists investigate the cosmos, the more they encounter phenomena that seem to belong to this hidden category. They leave measurable fingerprints on galaxies, stars, light, and the expansion of space itself. Their effects can be calculated, their presence can be inferred, yet their true nature remains unknown. This creates a remarkable possibility. The universe may be filled with forces, structures, and components that are just as real as the visible world, but remain beyond direct observation. We are able to measure their influence without seeing their source, much like hearing footsteps in another room while never seeing who is walking. The existence of such hidden influences suggests that reality may be far richer than appearances indicate. What we call the visible universe could simply be the surface layer of a much deeper system, where unseen forces quietly shape the cosmos from behind the scenes. Every new discovery seems to point toward the same conclusion. The universe contains more than meets the eye, and some of its most powerful influences may be completely invisible. The universe rarely reveals its deepest secrets directly. Instead, it leaves clues. These clues appear in the motion of galaxies, the behavior of light, the structure of space, and the evolution of the cosmos itself. Scientists often compare their work to that of detectives. They cannot always observe the source of a phenomenon, but they can study the evidence it leaves behind. In many cases, the evidence points towards something extraordinary, the possibility that unseen layers of reality exist alongside the visible universe. Throughout history, humanity has repeatedly discovered that reality contains far more than the eye can perceive. There was a time when people believed the night sky consisted only of the stars they could see. Then telescopes revealed countless additional stars hidden beyond human vision. Later, astronomers discovered galaxies beyond the Milky Way, expanding the known universe by unimaginable amounts. Each breakthrough delivered the same lesson: reality was larger than it appeared. Modern cosmology continues this pattern. As instruments become more advanced, they reveal signs that the visible universe may not be the whole story. The cosmos behaves as though unseen components are influencing its structure at every scale. These hidden influences are not random. They appear woven into the very fabric of existence. The most striking example comes from the large-scale arrangement of galaxies. When scientists map the observable universe, they do not find galaxies scattered randomly through space. Instead, they form vast interconnected networks stretching across hundreds of millions of light-years. These immense structures resemble filaments, bridges, and clusters connected together in what is often called the cosmic web. The existence of this cosmic web raises important questions. How did matter organize itself into such enormous structures? Why does the universe display patterns that seem too extensive to be explained by visible matter alone? Many models suggest that invisible influences played a critical role in shaping these colossal formations. The visible galaxies may simply trace outlines created by deeper, unseen structures lying beneath them. Another clue comes from the way light travels through space. Light moves across billions of light years before reaching Earth. Along its journey, it encounters regions of space that distort its path. Astronomers observe distant galaxies appearing stretched, bent, or magnified because something between them and Earth is altering the light. Sometimes the distortion is so strong that a single galaxy appears multiple times in the sky. The effect can only occur if enormous amounts of mass are present. Yet in many cases, much of that mass cannot be directly observed. The visible universe appears to be interacting with hidden components that reveal themselves only through their influence on light itself. The cosmos also presents mysteries involving the expansion of space. For much of the 20th century, scientists expected gravity to slow the universe's expansion. The reasoning seemed straightforward. Gravity pulls matter together. Over billions of years, that attraction should gradually reduce the rate at which galaxies move apart. Observations revealed something astonishing. The expansion of the universe is accelerating. Galaxies are not merely drifting apart. The rate of separation is increasing. Some unknown influence appears to be pushing space outward on cosmic scales. No one has directly observed the source of this effect. Scientists can measure the results with increasing precision, but the underlying cause remains one of the greatest mysteries in modern physics. It behaves like an invisible component embedded within reality itself, affecting the fate of the entire universe. The idea of invisible realms may sound like science fiction, yet history repeatedly shows that unseen aspects of reality become accepted once evidence accumulates. Before the discovery of radio waves, humanity had no reason to suspect that invisible signals were constantly passing through space. Before microscopes, entire ecosystems of microorganisms existed unnoticed. Before modern detectors, particles and forms of radiation moved through the world without leaving any trace visible to human senses. The hidden world was not created by the discovery. It was already there. Human understanding simply expanded enough to recognize it. This possibility becomes even more fascinating when we consider the limits of observation. Everything humans perceive depends on interaction. We detect light because it reaches our eyes. We hear sound because vibrations reach our ears. Scientific instruments also rely on interaction. They measure particles, radiation, energy, and forces because those phenomena leave detectable signatures. But what if certain layers of reality interact only weakly with the matter we are made of? What if entire structures exist around us while remaining almost completely invisible to conventional observation? Such realms would be difficult to detect directly, yet they could still influence the universe through gravity, energy, or other mechanisms not yet fully understood. Some theoretical models in physics even suggest that reality may contain dimensions beyond those we experience. These ideas remain unproven, but they emerge from serious attempts to explain unresolved mysteries. While scientists continue investigating such possibilities, the broader lesson remains clear. The universe consistently reveals more complexity than expected. Every major advance in astronomy seems to uncover evidence pointing beyond current knowledge. New observations solve one mystery while exposing several others. The deeper we look into space, the more the cosmos resembles a doorway rather than a destination. Each answer reveals additional questions waiting beyond it. The most remarkable aspect of these discoveries is what they imply about humanity's perspective. We naturally experience reality through a narrow window shaped by biology and limited observation. Yet the cosmos repeatedly demonstrates that existence extends far beyond that window. The visible universe may be only one layer of a much larger structure, just as the surface of an ocean represents only a small fraction of its total depth. If invisible realms truly exist, they may not be distant places hidden beyond the stars. They could be woven into the very universe we already inhabit, influencing galaxies, bending light, shaping cosmic evolution, and quietly affecting reality in ways we are only beginning to recognize. The clues are already present. The challenge is learning how to interpret them. The cosmos continues to whisper that there is more to existence than what we can see. Every unexplained influence, every hidden source of gravity, every mysterious acceleration, and every unanswered question points toward the same possibility. Reality may extend far beyond the visible world, and the universe itself may be revealing that truth one clue at a time. The most profound possibilities raised by modern science is that reality may contain entire layers that exist around us continuously, yet remain completely unnoticed. This idea may sound extraordinary at first, but history shows that humanity has repeatedly underestimated how much of existence lies beyond immediate perception. Again and again, discoveries have revealed worlds hidden in plain sight, existing all around us long before we developed the ability to detect them. Consider a simple example. At this very moment, countless radio signals are passing through the room around you. Wi-Fi networks, satellite transmissions, mobile phone signals, and other forms of electromagnetic communication fill the air. You cannot see them, you cannot hear them, you cannot feel them moving through space, yet they are present nonetheless. Specialized instruments can detect and interpret them, revealing a hidden layer of activity that would otherwise remain invisible. The same principle applies throughout nature. Before microscopes were invented, people had no awareness of bacteria, viruses, or microscopic organisms. Entire ecosystems existed beyond human sight. These invisible worlds influenced health, disease, and the environment despite remaining completely unknown. Their existence did not depend on whether anyone observed them. They were always there. This pattern suggests an important lesson. Human perception is not a measure of reality. It is merely a narrow window through which reality is observed. The senses that humans rely upon evolved to help our ancestors survive. Our eyes detect only a tiny portion of the electromagnetic spectrum. We see visible light, but we cannot naturally perceive radio waves, microwaves, infrared radiation, ultraviolet light, X-rays, or gamma rays. Yet all of these forms of radiation are real. They occupy the same universe and often the same space as we do. If such vast portions of the electromagnetic spectrum remain naturally invisible, it is reasonable to ask whether other hidden layers of existence might also surround us without being directly detectable. Modern physics occasionally points in this direction. Some theories suggest that reality may be more complex than the 3 dimensions of space and 1 dimension of time that humans experience. Certain mathematical models propose the existence of additional dimensions folded into the fabric of the universe. These dimensions would not necessarily be distant places located far away. They could exist everywhere, intertwined with ordinary reality while remaining inaccessible to everyday perception. Although these ideas remain theoretical, they illustrate a broader point. The universe may contain structures and levels of organization that operate beyond the limits of human observation. Just because something cannot be directly perceived does not mean it is absent. The possibility becomes even more intriguing when we consider how little of the cosmos we currently understand. Scientists have identified particles, fields, and forces that were completely unknown just a few generations ago. Entire branches of physics emerged from discoveries that once seemed impossible. Every major advancement expanded the boundaries of reality and revealed phenomena that had always existed but had gone unnoticed. Imagine a fish spending its entire life within the ocean without understanding that an atmosphere exists above the water. The fish would possess no direct experience of clouds, wind, rain, or the vast sky beyond the surface. From its perspective, the ocean would appear to be the entirety of existence, yet a much larger environment would surround it, remaining completely outside its awareness. Humanity may face a similar limitation. We naturally assume that the reality we perceive represents the full structure of existence. However, our perspective may be shaped by biological constraints rather than by the true boundaries of the universe. Astronomers have already encountered situations where invisible components appear to influence visible matter. Galaxies move as though surrounded by unseen mass. Space expands under the influence of unknown energy. Light bends around structures that cannot be directly observed. These phenomena suggest that reality includes important elements operating beyond ordinary perception. What if these hidden influences are only part of a larger picture? What if the universe contains layers that interact with our world in subtle ways, while remaining largely invisible to us? Such layers might not resemble planets, stars, or physical objects. They could consist of unfamiliar forms of matter, undiscovered fields, hidden dimensions, or entirely new categories of existence that current science has yet to identify. The challenge is that detecting such layers would be extraordinarily difficult. Human observation depends on interaction. We see objects because they reflect light. We hear sounds because they create vibrations. Instruments detect phenomena because measurable signals reach their sensors. Anything that interacts only weakly with ordinary matter could remain hidden for vast periods of time. This possibility forces us to reconsider a common assumption that what we observe defines what exists. Scientific history repeatedly demonstrates that this assumption is unreliable. Reality has consistently proven larger than the tools used to investigate it. The greatest lesson from modern cosmology is not that the universe contains mysteries. It is that the universe may contain entire domains of existence that we have not yet learned how to perceive. The visible world could be only one layer among many, much like a single page within a much larger book. If that is true, then humanity's current understanding of reality may resemble the earliest maps of Earth. Those maps captured certain coastlines accurately, yet vast continents remained undiscovered beyond the horizon. The map was not completely wrong, it was simply incomplete. The same may be true of our understanding of existence itself. The reality we experience every day is undoubtedly real, but it may represent only a fraction of a far greater structure surrounding us at every moment. Hidden layers may coexist with the visible universe, influencing it in subtle ways while remaining beyond ordinary awareness. And if entire layers of reality truly surround us unnoticed, then one of the most important discoveries of the future may not be finding something new. It may be learning how to perceive what has been there all along. Many people imagine science as a journey toward complete understanding. The common assumption is that each new discovery removes uncertainty and brings humanity closer to a final picture of reality. At first glance, this seems reasonable. Over the centuries, science has explained countless mysteries that once appeared impossible to understand. We learned that Earth orbits the Sun, that living organisms are built from cells, that matter consists of atoms, and that the universe extends far beyond our galaxy. Yet when scientists look back at the history of discovery, they notice a surprising pattern. Every major breakthrough has certainly answered important questions, but it has also revealed entirely new mysteries. In many cases, the new questions turned out to be even larger than the original ones. This is one of the most fascinating aspects of scientific progress. Knowledge does not simply replace ignorance, it often expands awareness of how much remains unknown. Imagine standing in a dark field at night with a flashlight. When the flashlight is turned off, very little can be seen. Turning it on illuminates a small area and reveals details that were previously hidden. At first, it feels as though the darkness is shrinking. But something unexpected happens. The larger the illuminated area becomes, the larger the boundary between light and darkness grows. More visibility creates more edges where new mysteries can appear. Science often advances in exactly this way. Before telescopes existed, humanity knew little about the true scale of the cosmos. The stars appeared as distant points of light, and many believed they represented the entirety of the universe. Then telescopes revealed planets, moons, nebulae, and galaxies. Instead of simplifying reality, these discoveries dramatically increased its complexity. The universe became far larger and more mysterious than anyone had imagined. The same pattern appeared in biology. Early scientists sought to understand the structure of living organisms. The discovery of cells answered important questions about life, but it also opened the door to genetics, molecular biology, and the intricate processes occurring within every cell. The deeper researchers looked, the more complexity they found. Physics provides some of the clearest examples. Isaac Newton's laws explained the motion of objects with extraordinary accuracy and transformed humanity's understanding of nature. For centuries, many believed these laws described the universe completely. Then new observations revealed phenomena that Newtonian physics could not explain. This led to Einstein's theories of relativity, which revolutionized our understanding of space, time, gravity, and motion. Yet relativity introduced new puzzles of its own. Questions about black holes, the nature of space-time, and the origin of the universe emerged as direct consequences of deeper knowledge. The story continued with quantum mechanics. Scientists developed this framework to explain the behavior of matter and energy at the smallest scales. The theory proved astonishingly successful, predicting phenomena with incredible precision. Yet it also revealed a reality that behaves in ways that often defy common intuition. Particles appeared to exist in uncertain states. Quantum systems displayed behaviors unlike anything observed in everyday life. Observation itself seemed to play an unexpected role in physical outcomes. The more researchers understood the microscopic world, the stranger it appeared. Rather than eliminating mystery, progress seemed to uncover additional layers of it. Modern cosmology follows the same pattern. Astronomers once hoped that mapping galaxies and measuring cosmic expansion would gradually produce a complete picture of the universe. Instead, observations revealed hidden influences that challenge current understanding. Scientists discovered evidence for invisible components affecting galaxies and the large-scale structure of space. They found that the universe's expansion is accelerating for reasons not yet fully understood. Each discovery solved one problem while exposing several more. This recurring pattern suggests something profound about the nature of reality itself. The universe may not be a simple puzzle with a final piece waiting to be found. Instead, it may possess layers of complexity that extend far beyond current understanding. Every time humanity uncovers one layer, another becomes visible beneath it. Consider the oceans of Earth. Early explorers could map coastlines and chart major routes across the surface. Yet beneath the water lay entire ecosystems, geological structures, and deep-sea environments that remained hidden for centuries. Even today, significant portions of the ocean remain unexplored despite advanced technology. Reality may be similar. What appears complete from one perspective may reveal deeper levels of complexity when examined more closely. Another reason scientific breakthroughs expose new unknowns is that discoveries often create entirely new tools. Telescopes revealed celestial phenomena that could never be seen with the naked eye. Microscopes exposed hidden biological worlds. Particle accelerators uncovered subatomic processes. Gravitational wave detectors opened a completely new method of observing the universe. Every new instrument acts like a new sense. It allows humanity to perceive aspects of reality that were previously invisible. As a result, each technological advance expands the territory available for investigation. The more we learn to observe, the more we discover that there is still left to observe. This does not mean science is failing. Quite the opposite. The emergence of new questions is often a sign that knowledge is advancing. Discovering unknowns means reaching the edge of current understanding and pushing beyond it. Some of the greatest scientific revolutions began with observations that did not fit existing explanations. Unexpected anomalies often become gateways to entirely new fields of study. What initially appears to be a problem may eventually reveal a deeper truth about reality. The universe seems remarkably effective at surprising us. Every generation has inherited a picture of reality that felt comprehensive, only to discover that important pieces were missing. What appeared complete was actually the beginning of a larger story. This is why the search for knowledge remains endless. The goal of science is not merely to accumulate answers, it is to continually refine humanity's understanding of a universe that may be far more complex than any single theory can fully describe. If reality truly contains hidden layers beyond current observation, then future discoveries will likely follow the same pattern. New breakthroughs will reveal new mysteries, new explanations will expose new questions, and every expansion of knowledge will illuminate previously unseen regions of the unknown. The most remarkable lesson is that ignorance does not disappear as understanding grows. Instead, it changes shape. Each answer transforms the landscape of mystery, revealing new horizons waiting beyond it. For this reason, every scientific breakthrough serves two purposes at once. It expands what humanity knows, and it exposes how much more there is still left to discover. In a universe that may be vastly larger and deeper than we currently understand, that process may never truly end. When we look at a city from above, the most noticeable features are the buildings, roads, bridges, and lights. These visible structures define the skyline and create the impression of a complete system. Yet beneath the surface lies another network that makes the city possible. Foundations support skyscrapers. Electrical systems power entire districts. Water pipes, communication cables, and transportation infrastructure operate largely out of sight. Most people never see these hidden systems directly, but without them, the visible city could not function. The universe may operate in a similar way. When astronomers observe the cosmos, they see galaxies, stars, planets, nebulae, and black holes. These objects appear to be the primary components of reality. They are the visible structures that fill astronomical images and dominate our understanding of space. However, as scientific observations have become more precise, evidence has emerged suggesting that these visible objects may rest upon a deeper and largely unseen framework. In other words, what we observe may be only the surface expression of a much larger cosmic architecture. One of the most remarkable discoveries in modern cosmology is that galaxies are not randomly scattered throughout space. When scientists map millions of galaxies across enormous distances, they find an intricate pattern stretching across the observable universe. Galaxies gather into clusters. Clusters connect through long filaments. Between these filaments lie immense regions known as cosmic voids, where relatively few galaxies exist. The result resembles a vast web extending across billions of light years. This structure is often called the cosmic web, and it represents one of the largest known patterns in existence. What makes this web so fascinating is that visible matter alone does not appear capable of fully explaining its formation. Computer simulations suggest that the early universe required additional invisible influences to organize matter into such enormous structures. Without these hidden components, galaxies would not have formed in the way astronomers observe today. It is as though the visible universe follows a blueprint that cannot itself be seen. Imagine watching leaves gather along the surface of a river. At first, the pattern may appear random, but if you study it carefully, you begin to notice that the leaves trace the shape of currents flowing beneath the water. The currents remain invisible, yet they guide the movement of everything on the surface. Many cosmologists believe the visible universe behaves in a similar way. Galaxies may trace underlying structures that remain hidden from direct observation. The stars and galaxies we see could be revealing the shape of an unseen framework supporting the larger cosmos. Evidence for this possibility appears in many areas of astronomy. Galaxies rotate in ways that suggest additional mass surrounds them. Large clusters remain gravitationally bound despite not containing enough visible matter to account for their stability. Light bends around regions of space that appear to contain far more mass than telescopes can detect. Again and again, observations imply the presence of hidden structures influencing visible reality. What makes this idea particularly important is that the invisible architecture seems to operate on the largest scales imaginable. We are not discussing isolated objects or rare phenomena. The evidence suggests that these hidden components may help determine how galaxies form, where cosmic structures emerge, and how matter is distributed throughout the universe. They may provide the scaffolding upon which the visible cosmos is built. The concept is not entirely unfamiliar. Nature often relies on hidden frameworks. A tree's branches spread across the sky, but much of its support system exists underground within an unseen network of roots. The roots anchor the tree, gather nutrients, and allow it to survive. An observer who sees only the branches gains an incomplete understanding of how the tree functions. Similarly, the visible universe may represent only the outward expression of deeper structures extending beyond direct observation. Modern physics also points toward hidden forms of organization at smaller scales. Atoms appear solid, yet they consist mostly of empty space organized by invisible forces. Matter itself is held together by interactions that cannot be seen directly. Fields permeate space and govern the behavior of particles. Reality often depends on structures that reveal themselves through their effects rather than through direct visibility. This recurring pattern raises an intriguing possibility. Perhaps hidden architecture is not an exception within the universe. Perhaps it is one of reality's fundamental characteristics. The deeper scientists investigate nature, the more they encounter systems supported by underlying frameworks that are not immediately apparent. Visible phenomena often emerge from deeper processes operating behind the scenes. The universe may therefore resemble a vast building whose supporting beams remain concealed within the walls. The room's windows and exterior design are visible, but the structure's true stability depends on components that cannot be easily observed. Remove those hidden supports, and the entire system changes. Some theoretical models go even further, suggesting that space-time itself could possess an underlying structure not yet fully understood. Space may not be the simple emptiness it appears to be. It may contain properties, relationships, and hidden levels of organization that current science has only begun to explore. Although many of these ideas remain subjects of active research, they all point toward the same conclusion. Reality may be supported by deeper layers than those immediately visible. This possibility transforms the way we think about the cosmos. The galaxies that fill the night sky may not be the foundation of existence. They may be the visible expression of something larger. The structures we observe could rest upon an unseen framework extending throughout the universe, shaping its evolution from the earliest moments after the Big Bang to the present day. If that is true, then the cosmos is not simply a collection of objects floating through empty space. It is a vast interconnected system supported by hidden architecture operating beyond ordinary perception. The most remarkable implication is this. Humanity may currently be studying the visible walls of reality, while only beginning to glimpse the deeper framework that holds everything together. The universe may be revealing its architecture piece by piece, inviting us to look beyond appearances and uncover the invisible structure beneath the world we know. An important question in science is not what we have discovered, but what we are still unable to observe. Human beings naturally experience reality through a limited set of senses. We see a narrow range of light, hear a limited range of sound, and perceive only a small fraction of the information that exists around us. For most of history, these limitations went unnoticed because people assumed that what they could perceive represented most of reality. Science has revealed something very different. Again and again, discoveries have shown that the universe extends far beyond the boundaries of human perception. Entire categories of phenomena existed long before anyone knew they were there. Radio waves crossed the Earth unnoticed. X-rays passed through objects unseen. Microscopic organisms lived, reproduced, and shaped ecosystems without anyone suspecting their existence. Reality did not suddenly create these things when they were discovered. They had always been present. Human understanding simply expanded enough to detect them. This raises a profound possibility. If so much of existence remained hidden in the past, how much remains hidden today? The observable universe itself demonstrates the limits of observation. Astronomers often speak of the observable universe as if it represents the entirety of cosmic reality. In truth, The term means something much more specific. It refers only to the portion of the universe whose light has had enough time to reach us since the beginning of cosmic expansion. Anything beyond that horizon remains inaccessible to direct observation. This does not mean nothing exists beyond it. It simply means information from those regions has not yet reached us. The observable universe may therefore be only a visible island within a much larger reality extending far beyond our ability to see. Imagine standing on a shoreline and looking across the ocean. The horizon appears to mark the end of the visible world. Yet everyone understands that the ocean continues beyond sight. The horizon represents a limit of observation, not a limit of existence. The universe may present a similar situation on a cosmic scale. Even within the observable universe, there are boundaries to what current technology can reveal. Telescopes collect light, but some regions of space are hidden behind clouds of gas and dust. Other regions contain objects so distant that their signals become incredibly faint. Certain events occurred so early in cosmic history that direct evidence is difficult to obtain. Every observation, therefore, arrives with limitations. Scientists often compare the process of studying the universe to attempting to reconstruct an enormous puzzle while many pieces remain missing. Some sections are visible, others are damaged, incomplete, or inaccessible. Yet even from the available pieces, it becomes clear that the full picture extends beyond what can currently be assembled. The challenge grows even greater when considering the nature of observation itself. Everything we know about the external world depends on signals reaching us. We see stars because light travels across space. We detect gravitational waves because instruments measure tiny distortions. We identify particles because they leave traces inside detectors. Observation requires interaction. But what if certain aspects of reality interact so weakly with ordinary matter that they leave almost no detectable signal? Such phenomena could remain hidden even while existing all around us. Their influence might be subtle, indirect, or difficult to separate from other effects. Entire categories of reality could therefore escape detection simply because current methods are not designed to perceive them. History provides many examples of this principle. Before the invention of the microscope, no one could study microorganisms because the necessary tools did not exist. Before radio technology, invisible electromagnetic signals remained completely beyond human awareness. In each case, the limitation was not reality itself. The limitation was observation. Modern physics occasionally encounters mysteries that suggest similar possibilities. Certain phenomena appear to influence the universe without revealing their true nature. Scientists can measure the effects, calculate the consequences, and model the behavior, yet the underlying source remains elusive. These situations remind researchers that observing an effect is not the same as fully understanding its origin. Some theoretical ideas push this question even further. Certain models suggest that additional dimensions, unfamiliar particles, or undiscovered fields may exist beyond current observational capabilities. These concepts remain unconfirmed, but they emerge from attempts to explain unresolved questions about the structure of reality. Whether these specific theories prove correct or not, they highlight an important truth. The boundaries of observation should never be confused with the boundaries of existence. The history of science repeatedly demonstrates that reality extends beyond what is currently measurable. Every generation has inherited tools that seemed powerful and complete, only to discover later that important aspects of nature remained hidden. Future scientists may look back on today's instruments the same way modern astronomers look back on the earliest telescopes. Valuable, revolutionary, but limited. This realization changes how we think about knowledge itself. Many people imagine that unanswered questions exist because scientists have not worked hard enough or gathered enough data. In reality, some mysteries persist because they lie beyond the reach of current observation. Solving them may require entirely new technologies, new theories, or new ways of thinking about reality. The universe has repeatedly surprised humanity by revealing layers of existence that no one expected. There is little reason to believe that this process has ended. The deeper scientists explore, the more they encounter evidence that observation itself may represent one of the greatest barriers to understanding the cosmos. We are attempting to study a universe billions of light years across while relying on signals that travel immense distances and instruments built on a small planet orbiting an ordinary star. Considering these limitations, it is remarkable that humanity knows as much as it does. Yet it is equally remarkable to consider how much may still remain beyond reach. There are regions of reality that current instruments cannot detect. Perhaps there are processes unfolding on scales too large, too small, too distant, or too subtle for present technology. Perhaps entire aspects of existence lie beyond the observational horizon of our civilization, waiting for future generations to uncover them. If so, then the greatest mysteries of the cosmos may not be hidden because they are impossible to discover. They may be hidden because humanity has not yet developed the means to see them. The universe continues to challenge every assumption about what can be known. Each new discovery pushes the limits of observation a little farther outward, revealing a larger and more complex reality beyond. And beyond every new horizon lies another horizon still waiting to be explored. What lies beyond the limits of human observation remains one of the most profound unanswered questions in science. The answer may redefine not only our understanding of the universe, but our understanding of reality itself. Throughout history, some of the greatest scientific discoveries began with a simple realization: something was missing. The motion of planets did not match expectations. The behavior of light revealed unexplained patterns. The structure of matter contained mysteries that existing theories could not answer. In each case, scientists followed the evidence, searching for hidden pieces that would make the larger picture complete. Today, humanity may be facing a similar challenge on the grandest scale imaginable. As astronomers and physicists study the universe, they repeatedly encounter signs that important components of reality remain unidentified. The cosmos behaves as though unseen ingredients are influencing its structure, evolution, and behavior. We can observe the consequences of these hidden factors, but their true nature remains one of the greatest unanswered questions in modern science. The search for these missing components is not driven by imagination or speculation alone. It arises from observations gathered over decades by telescopes, satellites, particle detectors, and other scientific instruments. Again and again, the evidence suggests that the universe contains more than what can be directly observed. Most striking examples involves the motion of galaxies. When scientists calculate how much visible matter exists within a galaxy, the numbers do not fully explain how the galaxy behaves. Stars move as though additional mass is present. The gravitational pull appears stronger than visible matter alone can account for. This discrepancy has led researchers to search for hidden sources of mass that may permeate the cosmos. Around the world, enormous experiments have been built deep underground, inside mountains, and beneath layers of rock designed to shield sensitive instruments from interference. These detectors wait patiently for signs of particles or phenomena that could explain some of the universe's missing mass. The challenge is extraordinary. Scientists are attempting to detect influences that interact so weakly with ordinary matter that they pass through planets, stars, and even entire galaxies with almost no trace. The search requires extreme precision and years of observation. Researchers are exploring the largest scales of the cosmos. Space telescopes map distant galaxies. Observatories measure the expansion of the universe. Sophisticated simulations attempt to recreate cosmic history from its earliest moments. Every new dataset provides additional clues about the hidden components shaping reality. Yet the deeper scientists investigate, the more complicated the mystery becomes. Some discoveries answer one question while creating several others. A new observation may explain a particular phenomenon but reveal inconsistencies elsewhere. This is a recurring pattern in science. Each solution often exposes deeper layers of complexity waiting beneath the surface. The search for missing components is therefore not simply a search for a single object or particle. It is a search for understanding. Scientists are trying to determine whether current theories describe reality completely, or whether important pieces remain absent from the picture. Imagine receiving a 1,000-piece puzzle with hundreds of pieces missing. Certain sections could still be assembled. Patterns would emerge. You might recognize landscapes, buildings, or faces, yet large portions of the image would remain unclear. The more you studied the puzzle, the more obvious the missing sections would become. Modern cosmology finds itself in a similar position. Scientists have assembled an extraordinary amount of information about the universe. They understand stellar evolution, planetary formation, nuclear processes, and many aspects of cosmic history, yet significant gaps remain. Certain observations continue to point toward components that have not yet been identified. The search extends beyond astronomy and into the microscopic world as well. Particle physics attempts to understand the fundamental building blocks of nature. Powerful accelerators collide particles at enormous energies, recreating conditions that existed shortly after the birth of the universe. Researchers analyze the resulting data, looking for signs of new particles, hidden interactions, or unexpected behaviors that could reveal previously unknown aspects of reality. These investigations are among the most ambitious scientific efforts ever undertaken. They represent humanity's attempt to identify the deeper ingredients from which the universe is constructed. What makes this search especially fascinating is that history suggests hidden components often exist long before they are recognized. Atoms influenced chemistry for centuries before they were directly studied. Electromagnetic fields shaped nature long before scientists understood them. Entire classes of particles remained unknown until advances in technology revealed their presence. The universe has repeatedly demonstrated that unseen elements can play essential roles in shaping reality. This lesson encourages humility. Human beings naturally assume that the visible world represents most of existence because it is the portion we experience directly, yet scientific discoveries consistently challenge that assumption. The more we learn, the more we realize that reality extends beyond immediate perception. There is also an important philosophical dimension to this search. If significant components of existence remain hidden, then humanity's current understanding of reality may resemble a rough sketch rather than a finished portrait. The sketch captures important features, but crucial details are still missing. Future discoveries may therefore transform our understanding of the cosmos in ways that are difficult to imagine today. Entire categories of phenomena could exist beyond current knowledge. New forms of matter, previously unknown forces, hidden structures, or unexpected properties of space and time may eventually emerge from ongoing research. The history of science offers many examples of ideas that once seemed impossible until evidence made them unavoidable. Continents existed before explorers mapped them. Microorganisms existed before microscopes revealed them. Gravitational waves crossed the universe long before detectors measured them. Reality often turns out to be larger than expectations. This is why the search for the missing components of existence remains one of the most exciting scientific pursuits of our time. Researchers are not merely gathering facts, they are attempting to uncover pieces of reality that may fundamentally reshape humanity's view of the universe. Every new telescope, every particle detector, every space mission, and every theoretical breakthrough contributes to this effort. Together, they form a global search for answers to questions that reach beyond individual disciplines and touch the deepest mysteries of existence itself. The possibility remains that some of the most important ingredients of reality have not yet been identified. They may already be influencing galaxies, shaping cosmic evolution, and affecting the structure of the universe while remaining hidden from direct observation. If that is true, then humanity is living during a remarkable period in history. We may be standing at the edge of discoveries that will reveal missing pieces of existence itself, and just beyond the limits of current knowledge, the next great chapter of understanding may already be waiting to be found. If reality is truly incomplete from our perspective, then the implications extend far beyond astronomy, physics, or cosmology. The idea does not merely change how we view galaxies, stars, or the structure of the universe. It changes how we understand ourselves. It forces humanity to confront a possibility that has appeared repeatedly throughout history: What we know may represent only a small fraction of what there is to know. For thousands of years, human beings have tried to understand their place in existence. Ancient civilizations studied the sky and created explanations for the movements of celestial objects. Later generations believed Earth occupied the center of creation. That view felt reasonable because it matched everyday experience. The ground beneath our feet appeared motionless, while the heavens seemed to revolve overhead. Then science revealed a larger reality. Earth was not the center of the cosmos. It was one planet orbiting an ordinary star. Later discoveries expanded the picture even further. Our sun was not unique. It was one star among hundreds of billions within the Milky Way. Then astronomers discovered that the Milky Way itself was only one galaxy among billions spread across the observable universe. Each discovery produced the same lesson. Humanity's position within reality was far smaller and more complex than previously imagined. Yet something equally important happened alongside these revelations. Every time humanity appeared less central physically, our understanding became more extraordinary intellectually. We learned that a species living on a small planet could uncover the laws governing stars, galaxies, and cosmic evolution. We discovered that curiosity allows conscious beings to explore realities far beyond their immediate surroundings. This creates an interesting paradox. The universe continually reveals that we occupy a smaller physical place than once believed, yet our ability to understand that universe continues to expand. We are both insignificant in scale and remarkable in awareness. If reality contains hidden layers beyond current observation, this paradox becomes even more profound. Humanity may not simply live within a vast universe, we may live within a reality whose full structure remains largely unknown. Imagine a person standing inside an enormous cathedral while carrying only a small lantern. The light illuminates nearby walls, columns, and pathways. These visible details are real, but they represent only a tiny portion of the entire structure. Vast sections remain hidden in darkness beyond the lantern's reach. Human knowledge may occupy a similar position. Science has illuminated remarkable portions of reality. We understand many laws of nature, can predict complex phenomena, and have explored regions of space once thought unreachable. Yet compared to the totality of existence, our illuminated area may still be very small. Beyond it may lie structures, principles, and forms of reality that remain undiscovered. This possibility encourages humility. Throughout history, people often assumed they had reached the limits of understanding. Again and again, those assumptions proved premature. New discoveries expanded the known universe and transformed humanity's worldview. If the pattern continues, future generations may look back on current knowledge as an important beginning rather than a final destination, is only part of the lesson. The possibility of an incomplete reality also inspires wonder. There is something extraordinary about living in a universe that still contains deep mysteries. A completely understood cosmos would leave little room for discovery. Every major question would already be answered. Every hidden corner would already be mapped. Humanity finds itself in a universe filled with unanswered questions. We do not fully understand the origin of cosmic structure. We do not fully understand the deepest nature of space and time. We do not fully understand why the universe possesses the properties it does. Some of the most fundamental aspects of reality remain open mysteries. These mysteries are not signs of failure. They are invitations to explore. The search for understanding has always been one of humanity's defining characteristics. Across cultures and centuries, people have looked toward the horizon and wondered what lies beyond it. That same impulse now drives the exploration of reality itself. The frontier is no longer a distant continent or an unexplored ocean. The frontier is existence. An incomplete reality also changes how we think about certainty. People often seek definitive answers because uncertainty can feel uncomfortable. Yet science repeatedly demonstrates that progress comes from questioning assumptions rather than protecting them. Some of the greatest breakthroughs emerged because individuals were willing to admit that existing explanations were incomplete. The recognition of ignorance often becomes the first step toward deeper understanding. This means that an incomplete reality is not a weakness in human knowledge. It is the reason discovery remains possible. If everything were already known, there would be no need for exploration. Every mystery solved would mark an ending rather than a beginning. Each answer reveals additional questions waiting beyond it. The cosmos therefore becomes more than a collection of stars and galaxies. It becomes a vast landscape of possibilities. Every hidden influence, every unexplained phenomenon, and every observational limit hints that reality extends beyond current understanding. The universe appears less like a finished book and more like a story whose later chapters have yet to be read. There is another implication as well. If reality is incomplete, then humanity's future may be shaped by discoveries that cannot currently be predicted. Previous generations could not imagine radio astronomy, space telescopes, quantum mechanics, or gravitational wave observatories. Likewise, future breakthroughs may reveal aspects of existence that today remain beyond imagination. Entire fields of knowledge could emerge from questions that are only beginning to take shape. New methods of observation may uncover hidden structures. New theories may reveal relationships between phenomena that currently seem unrelated. The boundaries of reality may expand in directions that challenge everything we think we know. This possibility places humanity in a unique position. We are living during an era when the universe is gradually revealing itself, yet much of the revelation remains unfinished. We possess enough knowledge to recognize that hidden layers may exist, but not enough to fully understand them. We stand between understanding and mystery, able to glimpse both at once. This is humanity's true place in the cosmos, not as masters who have solved the universe, not as insignificant observers lost within it, but as explorers living within a reality far larger than themselves, equipped with curiosity, imagination, and the ability to push beyond the limits of what is known. If reality is incomplete, then the greatest lesson may be that the story of discovery is far from over. The universe still contains unanswered questions, hidden structures, and unexplored possibilities waiting beyond the edge of current understanding. And somewhere beyond the boundaries of what humanity can presently observe, the next great revelation about existence may already be waiting. The possibility that reality is incomplete changes more than our understanding of the universe. It changes our understanding of ourselves. Throughout history, every time humanity believed it had reached the edge of knowledge, a larger reality emerged beyond it. Today, the same pattern may be unfolding once again. Hidden forces, unseen structures, and unexplored layers of existence continue to hint that the cosmos is far greater than it appears. What we observe may be only a small window into a much larger whole. And if that is true, then the greatest discoveries of the future will not be new objects or distant galaxies, but entirely new aspects of reality itself. Until then, one question remains open: how much of existence is still waiting beyond what we can see?